Lesson 2-3, Graph Quadratic Inequalities. Alright, so we're going to graph a quadratic inequality in 2 dimensions. So how do we do that? Well, start by graphing the parabola. Graph it as if it was a function. So you get your nice parabola. Then you decide if the line is solid or dashed. If it has the equal to, you see the equal to there, then it's solid. If it's not equal to, it's dashed. Then you have to decide where to shade. Now there's 2 ways to do that. Method 1 is you pick a test point. Find some point not on the line, plug it into inequality. If that point is a solution, you shade that side. If it's not a solution, you shade the other side. Or method 2, solve the inequality for y. See if y is greater than or y is less than. If y is greater than, you shade above the parabola. If y is less than, shade below the parabola. All right, here we are. Let's graph this. This is in intercept form. It's a x minus p x minus q. So I can see p, this would be like minus a negative, so p is negative 2, q is 4. Okay. The axis of symmetry was adding them together and dividing by 2 to get the average. So that is 2 over 2 is 1. Okay, so our vertex you get by plugging in that 1. So I'm plugging in the 1. And so we get, looks like negative 9 halves. This is 3, this is negative 3. Or negative, if you like, 4.5. All right, let's make a table. We can do it by hand or we can have our calculator. Let's have the calculator. So it's 1/2 x plus 2 x minus 4. All right, I want 1 to be the center, so let's go backwards a couple, maybe 3. 1 should go with negative 4.5. All right, let's see. Negative 3 is 3.5. Negative 2 is 0. Negative 1 is negative 2.5. 0 is negative 4. 1 is negative 4.5. 2 is negative 4. 3 is negative 2.5. And 4 is 0. And let's go ahead and put a 5 and 3.5. If you wanted to see what it looks like, hey, it opens up. All right, negative 3 and 3.5, negative 2 and 0, negative 1 and negative 2.5, 0 and negative 4, 1 and negative 4.5, and then the symmetry comes in. It's the same on each side. Now, is it solid or dotted? That's right, it is solid because it's less than or equal to. So let's draw a solid line parabola here. Now the shade. It's y is less than or equal. I'm using method 2. It's less than or equal. We're going to shade B low. So everywhere below that is shaded. And that's your graph. Let's try another one. What form is this in? That's right, this is in standard form, which is y equals ax minus h squared plus k. You see a is 2, h is 2, and k is negative 5. Our vertex is h, k, or 2, negative 5. Yeah, I wanted to put the parenthesis up there. 2, negative 5, that is the vertex. So now we make a table, 2 in the middle. Let's go less and more. Let's bring out our calculator. You can see the graph. That's what we expect. Our table, go down to negative 2, is 27. That's not going to fit on my graph. Then we have 13, 3, negative 3, negative 5. That was where our vertex was. Negative 3, 3. Now it's symmetric, 13 and 27. Let's just do those points right there. So 0, 3, 1, negative 3, 2, negative 5, 3, 4, 3. So it's coming in really steep, because remember the next point is at 13. Oh. Is this solid, or is this dotted? That's right, it is dotted or dashed, because it's just greater than, it's not equal to. So I need to do some erasing. So let's erase some spaces to make this dashed. Now how about our shading? So it's y is greater than, that means you're going to shade above. So the above would be inside the parabola. In this case, it's the only place where I can get above the line. You might have to graph a system of quadratic inequalities, which means you just graph each inequality on the same coordinate plane, and the solution will be all the places where they overlap. If there's no overlap, then there's no solution. All right, so let's solve this. All right, these are both in general form, so let's start with the first one. Our axis is, since we're in general form, negative b over 2a. b is the term with just x. That's not here. It's like we have 0x in the middle. So b is 0, a is 1, so 0. The axis of symmetry is at 0. So when I go to graph this, I have 0 in the middle. Let's see if we can get our calculator. Okay, so it's x squared minus 4. And that negative 4 says we have 12, then 5, then 0, and negative 3, and negative 4, and negative 3, 0, 5, and 12. Well, I'm not going to do the 4s because they don't fit on my graph. So I have negative 3, 5, negative 2, 0, negative 1, negative 3, 0, negative 4, and then it's symmetric. And this one is solid because it has the equal part. And this is shade. Let's see, it's y is greater than or equal to, so that means above. And I'm actually going to grab a highlighter to do the shading. So I'm above the line here. Everywhere that's above the line. Good enough. All right, let's change colors to do the other one. All right, the second one. All right. This is also in general forms. So our axis is negative b over 2a. b here is 2. A is negative 1, so I have negative 2 over negative 2, which is 1. So let's make a table. I'm going to have 1 be in the middle. Go backwards a couple. Forwards a couple. Let's grab the calculator and put this one on. On this calculator, I can actually put in more than 1. So it's negative x squared plus 2x plus 3. Now when you graph out, you can see both of them. And on the table, it's just over there. All right, I want x is negative 3, which is negative 12, negative 5, 0, 3, 4, 3, 0, negative 5, negative 12. All right, let's plot those. Again, I'm not going to do the ones where the y is in the 12, so I have negative 2, negative 5, negative 1, 0, 0, 3, 1, 4, and then we have symmetry. Our line is solid because it has the equal to. And our shading, its y is less than or equal to, so that means we are going below. So let's draw our curve. Let's grab a highlighter to do my shading. Shading below the line. It's down there. And so our solution, let's grab a different color highlighter, is everywhere where it overlaps. So that appears to be just this funny shape in the middle. So the green little lozenge looking thing. Just that overlap is the solution.